Hello everyone, my name is Shuangshuang and I'm from University of Jinan. Uh, the main content of my speech today is a survey of method for handling disk data imbalance. I will present it in three parts: an introduction, a main content, summary, and prospect. Next, we look at the first part, introduction. Background region. The mainstream device in the storage field is still the basic storage device, a hard disk. Due to the disk storage mechanism, once the disk is damaged, the data stored in it will be permanently lost. Therefore, the disk failure protection is particularly important. There is serious category imbalance in smart dataset, reflecting disk attribute information, which makes it difficult to predict disk failure purpose and significance. Generally, the classification model will bear the measures of data classes and ignore the minority classes, resulting in the difficulty of meaning the minority classes, resulting in the low classification accuracy of the minority classes. Therefore, it is very important to deal with the imbalance of data categories. This paper summarizes from many aspects and provides comprehensive reference for researchers in this field and chooses appropriate processing method according to their own needs. Informative abstract based on the research in the field of imbalanced data. This paper comprehensively summarizes and covers three aspects of data level methods: algorithm level methods and mixed methods, respectively. Summarize and analyze the problems solved by each type of methods, algorithm ideas, advantage and disadvantage, and this discusses the challenges and compelling strategies in the classification of unbalanced data. The second part is main contents. Different manifestations of the problem of disk imbalanced data classification. One, an imbalance in the dataset itself. The imbalanced classification problem of disk data is mainly manifested as too little disk fault sample data due to the limited information contained by a few classes. It is difficult for the classifier to fully learn the characteristic information of fault samples through trying, which makes it difficult to identify disk fault data, resulting in misclassification and loss. Two, limitations of traditional classification algorithm. Traditional classifiers usually aim to minimize the empirical risk and structural risk, so that the error rate is lowest or the interval between classes is largest. When the data distribution is unbalanced, a large number of samples belonging to the minority class in the overlapping part between classes will be misclassified, and the class spacing plan will be moved to the side of the class with parallels sample distribution, so that the classification accuracy of the algorithm for the minority class can't be guaranteed. Data-level methods, including oversampling, undersampling, mixed sampling, and a generative model. The simplest oversampling method is random oversampling which balance the number of sampling of two categories by coupling a few columns of samples. However, increasing a few class samples to expand the sample space will lead to excessive redundant overlapping data, resulting in the classification model overfitting the copied samples. Undersampling as a no heuristic learning method, undersampling can effectively elevate the imbalance between the majority class and the minority class by randomly discarding some of the majority class data to establish a classifier. Makes the simpling. Both oversampling and undersampling methods have different defects. In order to obtain better classification results, the combination of oversampling and undersampling method provides a new direction for an unbalanced classification. After combining two different sampling methods in different regions, the classification effect is improved. Generative model based on exciting real data that already exists, generate the required data to expand the dataset and elevate the imbalance of dataset. Algorithm-level method, including cost-sensitive method and integrated approach. The classifier using the cost-sensitive method assigns different weight properties to its input training sample. Through that method, the higher weights can be assigned to minority class samples, with increasing the importance of minority class in the process of training the model, makes the classifier favor minority class and reduce the misclassification caused by class imbalance. Integrated approach focus on single class learning of target group and create data descriptions. In that way, we eliminate bias towards any group, as we are only focusing on one set of objects. However, some specialized approach is needed to use a class of learners to solve more complex problems. Integration places such as bagging, boosting, and sticking. The last one is mixed method. Due to the continuous improvement of data level method and algorithm level method, mixed method is widely used, which use the mixed method to combine data level method with classifier integration to produce a classifier with good classification effect. In many researchers on disk field prediction, mixed method have been used to achieve higher classification accuracy and better classification effect. Also, the unbalanced dataset classification based on mixed method has achieved excellent results. The training process of integrating a based classifier is more complicated and time consuming. At the same time, how to choose base classifiers and integrated algorithm to better adapt to solve objective is roles considering when use mixed method. The last part is summary and prospect. In that paper, the solution to the problem of positive and negative sample imbalance in disk field prediction are sorted out and analyzed from data level method or algorithm methods and mixed method. And the feature research focus and direction of the analysis and put forward opinions. That paper provides a comprehensive reference for researchers in this field to choose the appropriate treatment method according to their own needs. Next is prospect. One, in recent years, Qiang has been widely used in image generation, which can realize the fake image generation and has made great achievement. According to the properties and distribution of disk data, a GAN model can be designed to generate fake data, which is similar to the real disk data distribution and has the same properties. That method can avoid overfitting and information loss caused by undersampling. Two, for algorithm level method to deal with disk data imbalance. Due to the characteristics of disk data itself, some type of disk have a high failure rate, while others really fail. However, a disk failure prediction is very important for all disks. So it is a good research direction to study the use of transfer learning to solve the problem of poor classification prediction caused by the imbalance of positive and negative disk data samples. That's it all. Thanks.